so let's take a look at these examples. So in these diagrams, the body is accelerating as shown. Find the magnitudes of the unknown forces x and y. So I have this force system here. I have an object which is which has a mass of 2 kilograms. It's accelerating in that direction at a rate of 2 meters per second squared. Okay, so the first thing we're going to do is we're going to consider the vertical forces. Now, there is no acceleration in the vertical direction, so it is in equilibrium in that direction. So if I resolve vertically, so I'm going to find the resultant force vertically, I am going to say y, taking that as my positive direction, minus 2g is equal to 0, because there is no acceleration in that direction. So y equals 2g, which equals 2 times 9.8, which is 19.6 newtons. Okay, so to find this force here, x, we need to resolve in the horizontal direction. I'm going to go in that direction because I know the acceleration is that way, and I'm going to use F equals ma. I'm going to apply Newton's second law. So I need to find the resultant force in this direction. So the resultant force in this direction is this force minus this force. Can we see that those two forces, because they are perpendicular, have no effect in the horizontal direction? So x minus 4 is the resultant force in that direction. So that is equal to mass 2 times acceleration, which is 2. So x is equal to 4 plus 4, which is 8 newtons. Okay, so a similar idea on this one here. So this time the acceleration is in that direction. I'm looking to find x and y. So again, it's a fairly similar process. I will resolve in the vertical direction. I'm going to take up as the positive. Now just be careful as to which direction these arrows are in. This would be a common mistake. So if I take up in this direction, I've got y. I have got a minus 20 because the 20 is in the downward direction. My 4g is in the downward direction, so that is negative force, and that is in equilibrium in that direction, so the acceleration is 0, so that all equals 0. So y is equal to 20 plus 4g, which equals 20 plus 4 times 9.8, which is 59.2 newtons. Okay, we're going to take the we're going to resolve horizontally this time. It actually doesn't matter which direction we go in. I think what I'm going to do is I'm going to go in this direction here. I'm going to go to the left because that is the direction of the acceleration. So the acceleration is positive in that direction. So being very careful which direction I'm going in, I've got 80, which is positive in that direction, minus x is equal to mass, sorry I should write F equals ma there, mass, which is 4, times acceleration, which is 2. It's positive 2 in that direction. So x equals 80 minus 8, which equals 72